17A students, someone asked for a video about higher order derivatives, so here are a few examples. So this says I'm going to find f triple prime of x for f of x equal to e to the negative x times cosine of x plus x squared. So we have a couple things going on here. One, we have a product rule. We have e to the x times cosine of x, maybe think of that as u and v, and x squared. Also, e to the negative x is a little bit more special. The derivative of e to the x is e to the x. The derivative of e to the negative x, well, is e to the negative x times the derivative of negative x, which is negative 1. So just as an FYI, the derivative of e to the negative x is e to the negative x times negative 1. Because of the chain rule, right? The derivative of e to the stuff is e to the stuff times the derivative of the stuff. In a similar way, just to kind of point it out, the derivative of e to the x to the fourth would be e to the x to the fourth times the derivative of x to the fourth, which is 4x cubed. So let's find the first derivative. So when you're finding higher order derivatives, when they're like this, it just means you have to do repeated differentiation. So it's going to be, okay, product rule, the derivative of e to the negative x is e to the negative x times negative 1, which we usually put the negative in front. Leave the cosine alone. Plus, then we do the reverse. You get e to the negative x times the derivative of cosine, which is negative sine. Plus, the derivative of x squared is 2x. All right, yeah. So now the second derivative. You have to use the product rule for each of these pieces. Normally I bring out the negative, but I'm just going to keep it with each piece. So the derivative of negative e to the negative x is negative e to the negative x times negative 1, which is positive e to the negative x. The nice thing about e to the negative x is it just kind of keeps going back and forth when you keep repeating its derivative from positive to negative. So then we have times cosine of x plus negative e to the negative x times the derivative of cosine, which is negative sine, plus the derivative of the negative x, which is negative e to the negative x times negative sine of x, and then do the other thing, right? Leave this alone, you get e to the negative x times the derivative of negative sine is negative cosine, plus the derivative of 2x is 2. And then on this step we should definitely simplify. This is e to the negative x, cosine of x. A minus is a plus, and this is the same. So it's a plus e to the negative x times sine of x 2 times. And then you have an e, oh look. You have, so really I don't even need to write this, because this e to the negative x cosine x and this e to the negative x negative cosine x cancel out. And then finally we take the derivative. So I'm going to treat this as one piece of my product. So the derivative of 2 e to the negative x is 2 e to the negative x times negative 1 times sine left alone, plus 2 e to the negative x times the derivative of sine, which is cosine, plus 0. And I would probably finally write this answer as this part first since it's positive. So 2 e to the negative x cosine of x minus 2 e to the negative x times sine of x. That's it. Okay, and then for ones where they're done, where you have like lots of derivatives, I'm going to change. I'm going to add one in here. I'm going to do e to the negative x and then e to the 3x. So what's the 103rd derivative of sine? Well, here's the thing. We know every fourth derivative of sine is equal to sine. So I know that for sine of x, the fourth derivative of sine of my function, if I call this f of x, sorry, that's equal to sine of x. I know the 8th derivative is equal to sine of x. And every multiple 4 derivatives. So I know all the way to the 100th derivative of this function is sine of x. And then I can take 3 more derivatives. The 101st derivative, well, the derivative of sine is cosine. The 102nd derivative, well, the derivative of cosine is negative sine. And finally, the 103rd derivative, well, the derivative of negative sine is negative cosine. So, if you're going to take 103 derivatives, you just take out the biggest multiple of 4, and then there's 3 left over, and you do 3 derivatives of sine. If it was sine of 2x, it's a little more interesting, because the first derivative would be, right, so I should say, the first derivative would be cosine of 2x times 2. And then the second derivative would be negative sine of 2x times 2 times another 2. And then the third derivative would be, that's the third derivative, would be negative cosine of 2x times 2 squared times another 2. And so it looks like every derivative is going to have, in addition to having the trig function, it's also going to have 2 to that derivative power. So the fourth derivative would get you back to sine of 2x, but you'd have times 2 to the fourth. And so we actually can see, well, I see the pattern, right? I know the 103rd derivative of sine was negative cosine of x. So the 103rd derivative of sine of 2x is going to be negative cosine of 2x. Sorry, my writing is getting terrible. So it's negative cosine of 2x times 2 to the 103rd power. That would be the 103rd derivative of sine of 2x. Okay, let me cordon out some space here. Sorry. E to the x is super easy. The 103rd. So again, I should really be more careful here. I should call these all things. Like I'm gonna say g of x is e to the x. Well, the 103rd derivative of e to the x is e to the x, because the derivative of e to the x is always e to the x. Okay. For f of x equal to e to the negative x, well, let's see. We know they alternate. The first derivative is negative e to the negative x. The second derivative is positive e to the negative x. The third derivative is negative e to the. So it looks like every even derivative is positive, every odd derivative is negative. So I know that the 103rd derivative, which is an odd derivative, should be negative e to the negative x. Last one here. For g of x equal to e to the 3x, the first derivative is e to the 3x times 3. The second derivative is e to the 3x times 3 times another 3. So just like with the sine of 2x one, it looks like every subsequent derivative is going to multiply by 3. Sorry, the second derivative is e to the 3x times 3 squared. The third derivative would be e to the 3x times 3 cubed. And the 103rd derivative is going to be e to the 3x times 3 to the 103rd power. So hopefully that helps a bit with the repeated differentiation. Do let me know if you have any questions. I'll see you guys on Monday.